Okay, it looks like today we have another integral. This one's from MIT 2012. Problem number 6. We have the integral of dx over the square root of 1 minus 4x minus x squared. Not a lot of reason here to look around for different methods. I think what we want to do is just kind of factor the denominator here and then try to use a trig substitution. What I'd like to do is get this, if I could get this to look like u squared right here, then we'd have 1 minus u squared. We could do a trig substitution for sine. So I think what I'll do is we'll just focus on this minus 4x minus x squared part, and I can factor a minus out of that. So we'll write this as 4x plus x squared. Then from here, what I can do is I can complete the square on this. So I can write it as x plus 2 squared. Just noticing that's going to give me back, when we square this up, we're going to have an x squared. We're going to have 2x plus 2x. We're going to have a 4x. But we're adding an additional 4. So what we need to do is subtract that off so that we're not changing it. But before I put this back in our integral, let's distribute this minus sign back in. So we can write this as 4 minus x squared plus 2 squared. So now putting this back in our integral, we're going to have our dx. And then we have our 1, but we're going to add it to 4. So now we have a 5. And then we're just going to have this piece minus x plus 2 squared. And then again, for a trig substitution, we want to have this term squared as well. So I'm going to write this as square root of 5. Instead of having 1 minus u squared like I planned, we have this additional number. So we're going to have square root of 5 squared minus x plus 2 squared. This is still good for a trig substitution. So for the trig substitution, we want to do this again. We want to do this for sine. So I'm going to use this x. I'm going to substitute for x plus 2. And we will do sine t. But we have this, we're not dealing with a 1. We're dealing with this square root of 5. So I can just put a square root of 5 in front of my sine t. Just noticing that if we look at what's x plus 2 squared, that's going to be 5 sine squared of t. Then next, let's just find our dx. So I'll take a derivative here. So derivative of x plus 2 is just going to be dx. Derivative on the right is going to be square root of 5. Derivative of sine t is going to be cosine t dt. Then one thing I like to do before I substitute, I want to solve for a t, so let's just go take this down here. So if I divide by square root of 5 on both sides, we can have x plus 2 over square root of 5 equals sine of t. But then I'll just take the inverse sign on both sides, and we're going to have our t is going to be arc sine or inverse sine of x plus 2 over square root of 5. Okay, so now I think we have everything we need to substitute. So for our dx, we have our value right here. So we're going to have square root of 5 cosine, that's kind of a weird square root, cosine t dt. Then in our radical, we're going to have 5 minus our x plus 2 squareds right here. So this is going to be 5 sine squared of t. Then I can take a square root of 5 out front of the integral, right? But we also can factor a square root of 5 out here. We can factor out a 5, and then it's inside the radical, so that's going to be another square root of 5 we'll have in the denominator here. That'll just cancel the 1. Then we're going to have cosine t dt. And this is going to be 1 minus sine squared t in the radical. But this piece right here, this is just cosine squared. 1 minus sine squared t is the same thing as cosine squared t. It's in the radical. Now technically, if we take the square root of cosine squared t, we would get this piece being absolute value cosine of t. But what we're going to do, we're going to remove the absolute value. This is always going to be positive, and that's because in the beginning, we had to restrict the domain. You can see that a lot of values aren't going to work here if you put in, like, say, a 3. So we'll assume this to always be positive. This will cancel out, and we're just cosine cancels with cosine, so we're integrating just 1 dt, and we're going to have t. But luckily, we planned ahead. We have our t value right here, and so for our solution, we're going to have sine inverse x plus t square root of 5 plus c. That's it. There's our solution. So thought it was a pretty good problem. I know it's just a kind of a standard trig substitution kind of problem, but good one all the less. So thank you for watching. Please like and subscribe. Have a great day.